Hello and welcome to KISS Math. So far, we have only been doing operations on real numbers like 1, 2, and 3, and not fake numbers like x, a, and b.
It's all fake
But
news.
actually, these fake numbers are just as real as the real numbers. The only difference is that we don't know what they are. Their value could vary, which is why they are called variables. The most common variable is labeled as x, but it can be any letter like the ones here. They just represent some value that is not known yet. Most problems in algebra will be figuring out the value of these variables. To show you what I mean, let's say that x is some unknown number, and for whatever reason, we want to multiply it by 3 and then add 5 more to it. Now, if I were to express this, I could write this as 3 times x, we're multiplying by 3, and then we add 5 to it. Now, I still don't know what the value of this expression is because x could still be anything. But if a little birdie comes along and tells me that x is actually equal to 4, well, then I can go back in and substitute the number 4 every time I see an x, because I know that x is the same as 4. So if I do that, this would become 3 times 4 plus 5, which is 12 plus 5, and that's 17. If instead another birdie told me, no, x is not equal to 4, x is actually equal to -3, well, then I would substitute in a -3 every time I saw an x. So I would have 3 times -3 plus 5, which is the same as -9 plus 5, and that is -4. Now, whenever I am substituting a known value for x, I can say that I am evaluating the expression. Expressions. I just mentioned this word a few times when talking about variables, and it probably already made sense to you. Expressions are a way of writing something out so other people can understand them. With language, we express things with words. In math, we express things with numbers. But there are some key words or clues that help us translate our words into numbers. Here are some common ones, and I'll start with addition. If somebody says 4 more or 4 greater than some number, we can express that as x plus 4. And this x here is representing some number. And actually, it could be any letter, like a plus 4. It's just some symbol that represents the unknown. Now the clue words here are more and greater. They're indicating addition. The sum of some number and 5, this can also be written as x plus 5. Here, the word sum is telling us addition. For subtraction, if someone says 6 fewer than or 6 less than some number, we write that as x minus 6. This is not the same as saying some number fewer than x, because that would be 6 minus x. And we know 6 minus x is not the same as x minus 6 from our commutative properties. People can also indicate subtraction by saying 13 less some number. And that can be just read as 13 minus some number and written as 13 minus x. The difference of 13 and some number, we can also write that as 13 minus x. And the difference of some number and 13, well, that would be x minus 13. Again, with subtraction, the order does matter, and these two do not have the same meaning. So the clue words for subtraction are fewer than, less a number, and difference. Here are some clue words for multiplication. When you multiply something, the result is called the product. So the product of some number and 3 would be written just as 3x. Multiplication is commutative, so the order doesn't really matter here. So I could say the product of 3 and some number is also 3x. Or I could write that as x times 3. Anything when you're doubling or tripling or even having some number would be considered multiplication. And it could be written as 2x for doubling, 3x for tripling, or 0.5x for halving. 1/3 of some number is technically dividing some number by 3, but it can also be seen as multiplying some number by 1/3, and you'd get the same result. For division, when you divide something, the result is called the quotient. So the quotient of 20 and some number means 20 divided by some number x, or we can write that as 20 over x. Division is not commutative, just like subtraction, so you have to be careful with the order. Also, get used to writing this as a fraction. We will rarely use the division symbol here, this guy. And like I said before, you can take 1/3 of a number by multiplying it by the fraction 1/3. So 1/3 times some number x, or just simply taking that number and dividing it by 3. So here's an example. If someone says, what is 3 less than 1/5 of some unknown number x? Well, so we have our unknown number x, and we are talking about 1/5 of that. So I'm going to multiply it by 1/5. And what is 3 less than that? So we're going to do minus 3. If it were instead, what is 3 less 1/5 of some unknown number x? It would be 3 minus x times 1/5. You see, if you take away that word than right here, that changes the order of the subtraction and you'll get two completely different results. So you have to pay real close attention to the wording. If someone says, what is 3 times the quantity x plus 3? Quantity can be translated as pretty much parentheses. So 3 times parentheses x plus 3, which we can write that as 3 times parentheses x plus 3. We're multiplying this 3 by the entire amount or quantity of this x plus 3. The word quantity is important because it's telling you to do the addition of x plus 3 before multiplying it by 3.